All right. Good morning, everybody. It is August 30th, and welcome to the working group weekly meeting. To start off, we'll announce some new members. We have Daryl Finnegan from Agriculture and Agri-Food Canada, who I do not see, I don't believe I see on the call here this morning. And also Salman Khan from the CSA group, who I also believe is not on the call this morning. So unfortunately can't have them give an introduction, but that's all right. So moving on from there, I would like to pass things over to the folks at Haggerty AgRobotics. We've got their summer interns here, and they're going to be giving a summary and overview of what they did over this past season and give us some updates on their experiences. So Kate, Hassan, Jing, Thomas, and Dexter, I'll pass things over to you.
All right, thank you. Thanks everyone for coming. We're the Haggerty Summer Team, and we're going to be sharing what we've been up to this summer. Oh,
Oh.
my slide controls. Oh, wait. How do you? There we go.
Oh.
Too far. How do you go back? Oh, there we go. There we go. I fixed it. All right, so we're the Haggerty Summer Team. So I'm Kate, and I'm joined by Thomas, Hassan, Dexter, and Jing. And we are going to be providing an update on our projects and experiences for the summer. So I'm going to start us off. My name is Kate Barisic. I'm the digital media specialist at Haggerty AgRobotics. I study at Sheridan College in Oakville. I've done 2 years of general visual arts, and I'll be starting my Bachelor of Illustration in September. I've been working with Haggerty for a couple years now, and I also work on our family's farm. I do the custom application of fertilizer for myself and my family, and for some customers in our area. My main job at Haggerty Robotics is to manage these social media accounts. We have 5 accounts across 3 platforms, LinkedIn, Twitter, and Instagram. So I manage the main ones with the exception of the Haggerty Techs account, which is run by the techs. One of the things I was able to do this summer was myself, along with Curtis, we had the opportunity to do a social media consulting sessions, and with that, we were working on making a cohesive company appearance across all of our social media platforms, and making sure that we were becoming we had a more noticeable presence online. So one of the first things I did with that was to come up with a brand palette for Haggerty Robotics. So these are the main colors and fonts that I use in the advertising and our posting and everything, so that we have a cohesive appearance across platforms. I also came up with a content schedule. So right now we're posting twice a week on all 3 platforms, just so that we know if we have enough content to post and what needs to go out when for promoting events and other things that Haggerty is doing. So these are just some examples of promotional materials that I made. So flyers for demo days, upcoming events, and then advertisements for the company. I work with Adobe InDesign to make my flyers. So this is just an example of our handout that we do and how it would look if I was working on it. So you can see all of the layers, which each one of those would be an individual block of text or an image or a shape on the page, and then the controls to format it. This is just a glimpse into my design process. So I usually start with a really, really, really rough sketch. It doesn't really look like anything. It's a little hard to tell, but in the sketch image, the top right rectangle is the closest to the actual design that I would do. And then I go in and I make a rough outline with colors to see if I like shapes, if I like colors, general layout. And then it's not done yet, but this is the working final. And you can see that even that is different than my plan. So I usually go through at least 4 or 5 different versions. of these posters before I come up with a final one. My biggest project for this summer was to revamp the Haggerty AgRobotics website. Um, we had a pretty solid website already, but it was out of date, and we've done a lot since it had last had a big update. So I went through the entire website and I made point form notes about what needed to be added, what needed to be changed. And then I went into Adobe Illustrator and I rebuilt the whole thing just as flat pages so that I could arrange text and shapes and images in a way to make it easier to see, to plan, and decide where I wanted things to go before I moved on to the actual website. Um, Along with that, I do a bit of photo editing. So I take a lot of photos for the company that are used on the website, on our social media, and for different articles and stuff that Haggerty puts out. So when you take photos outside, a lot of the time the colors and the exposure will be slightly mixed up because it's so bright. So I go through, I use Adobe Lightroom and I edit slightly just to bring the colors back to what it would actually look like in real life. So these are just a few examples. You can see I removed some objects, I fixed the colors, I fixed the lighting to make it look better. And that's it for me. So I'm going to hand it over to Thomas.
Good morning, everyone. Thanks for joining us today. My name is Thomas McClay. I am the Research and Technician Supervisor here at Haggerty AgRobotics. Some of you might remember me from last year, where I was just a research and technician, but now I'm back and I've got that supervisor role. So a little bit about me. I've completed 3 years of mechatronics engineering at the University of Western Ontario. And how I actually found Haggerty AgRobotics was actually through school. In second year, for those of you who went into engineering at Western, know that we have to write an essay course. And in the essay course, believe it or not, you have to write an essay. And my essay was actually, I chose to write it about farming and things we could do to improve the current situation in farming. And what I found is these robot applications could be really, really beneficial. And through my research, I actually found Haggerty AgRobotics, decided, hey, I wonder if they hire summer students. Sent the info email asking if they hired summer students. And here we are a year and a half later, and couldn't be happy to be a part of this team. So a little bit about me is that I actually don't come from a farming background. I come from the suburbs, like I'm sure many of you do as well. But through my experience here, I actually found a real passion for agriculture. And for lack of a better term, I can see myself within this field for much longer. So yeah, I'll go into a little bit about what I've done this summer. So the first project I worked on is, I'll give you a high level as to what it was about here first, is that, so within lima beans in Ontario, weeds are a big issue, like with all crops. Something that I learned is that sometimes the weed density is so high within a certain section of the field that they won't even harvest that section of the field. So that's pretty interesting. So right now, the current method for scouting fields is they'll just send a human out there. They'll do an M in the field or just a V to get a rough idea of where the weeds are, but that's really just a rough idea. So we're trying to create a system in which we can get a much clearer picture as to where these weeds are within the field. And so that's what we've built here, is a AI system, an AI algorithm that we can use in conjunction with images to detect where exactly these weeds are within the field, to give the farmer a bigger picture or a better picture as to how to manage his field or his or her field more efficiently. So to do this, to build this model, obviously we need thousands and thousands of photos of lima bean fields. And to do that, it's a little bit annoying to just go out there with your iPhone and take a bunch of photos. So what we decided to do is we decided to build this boom, which you see on the right there, that'll house 6 different cameras to take a bunch of pictures more efficiently. So my task was actually to build this boom, to design this boom. And to do that, because I don't come from a farming background, me and Jason actually decided to go to a farming junkyard to get an idea of what farming engineering practices are currently being used to build farming implements. So that was a pretty cool experience, just to see all the different hinge designs people were coming up with and all the mounting mechanisms and things like that. So that was pretty cool. And so that's how I came up with the design that you see on your right, which was built in SolidWorks. So that way we could make adjustments to the design without actually having to build it first and then making adjustments in real life. So there you go. You've got your design, and now here it actually is in real life on the HCT robot, which is an autonomous farming robot there. So as you can see, it's got 6 different cameras, and it spans about a 30-foot swath width. So that way we can do 30 feet passes along the rows there. So that created taking pictures a lot more efficient. And so that was pretty interesting to get that done. And so here you can actually see the boom in action. So personally, this was a pretty cool experience for me because I had never actually designed anything. In school, you design things in theory, but I've never actually designed something that was actually built. And to see what I had actually designed, built, and used in the field to see what worked, what didn't work, and what adjustments could be made next year was a pretty cool experience just to see all of that. So here you go. Here you go on the left, you can see it on the Gator, and that's it in the middle, also on the Gator, but can also be attached to what you saw before on the HCT for a more autonomous operation. So that was the lima bean imaging project. The next thing I worked on was an electric planner. Now, some of you may be asking, why don't we just use normal hydraulic planners? Well, that's because most of our robots are electric. They don't have hydraulic systems on board. So we can't use hydraulic planners. So what we've decided to come up with is we actually bought these electric planners from the company called Wizard. And with Chuck's not gonna like that I use this word, but from a piece of garbage from his backyard, as you can see on the left, it looks like it's from the Titanic, let's be honest. This old piece of farm equipment, as you can see in the middle, we cut it down, we polished it, painted it, and now it looks as nice as it does. You can see it on the right there, the finished product with those 2 electric planners. We actually do plan on adding 2 more rows to that planner, and this will be used on the Nio Oreo, which you will see my coworker Dexter will talk about in a little bit. And the last project I worked on was actually the Nio Oz. So the Oz is like a single row robot. It's more meant for like market garden applications. So this comes from Nio from France there. And so one of the challenges we had this summer was with these robots and their battery life. It wasn't exact. They had claimed that it was supposed to go for about 8 hours, and we were finding that it wasn't doing that. So one thing I did was to analyze what their actual battery depletion was and how that was going. So I took a whole bunch of points to see how long it took for it to deplete and made a graph and stuff and sent that to them. And with them, we created a plan as to how to resolve this issue. And so that's it in the middle. You can see that's me testing the maps. You can actually see how straight it is at following these lines. Those are the lines that it created in the grass. So that's pretty cool to see. And then on the right there, you can see the Oz actually in the field doing what it's supposed to be doing, weeding and such. So that's it for me. I will pass it along to my coworker Hassan, and he'll tell you what he was up to this summer.
All right. Hey, everybody. My name is Hassan. I got the opportunity to work as a researcher and technician this summer at AgRobotics. I'm currently going into my 5th year of computer engineering at the University of Guelph, and I'm specializing in artificial intelligence and robotics. The main reason I chose to apply to Haggerty is because I'm very passionate about implementing all the different abstract robotic principles that I've been learning in university in the agricultural field. And I think Haggerty AgRobotics, being at the bleeding edge of this technology, is really the place to be for this industry. So moving on to what I did in the summer, my responsibilities were mostly focused on the TED, which is one of Nio's vineyard straddling robots. On the left-hand side of the screen, you can see what a typical day in my life looked like. One of my main responsibilities with the TED was trajectory mapping. This involved collecting GPS data with an RTK beacon across the vineyard rows at Cave Springs Vineyard. The beacon will collect data at 100 millisecond intervals. This data was then imported into Nio's mapping software, where it was clustered, enabling me to create an actual path for the robot to follow. Once this path was made, we had to test if this path was accurate. So we would test to make sure that it is close enough to the vines, not damaging the vines, and also that it's adequately covering the vineyard. In addition to this, we also had to record paths to connect different parts of the field together into one cohesive map. So if you reference the picture at the bottom of the slideshow, The lines in green represent the paths that the TED would take while cultivating the rows, and the lines in blue represent the path that the TED would take to get from one area of the map to another without any damage. I also had the opportunity to collaborate with the NIO support team in France, as well as with Grant over at the Haggerty head office, to troubleshoot various technical issues that we had along the way, including a motor replacement and also compass calibration. Throughout the summer, I also got the opportunity to work on some research and development projects. Specifically for the scouting or imaging project that Thomas was discussing, my task was to design camera covers for our cameras that we were using, with the objective to prevent dust from getting into any of the ports and also to dissipate some of the heat that the cameras would face being outside in the sun. I did this by designing a model in SolidWorks by applying various design techniques to ensure that the model fits seamlessly with the camera. In addition to this, we also had to 3D print this model. So I had the opportunity to perform a little bit of materials analysis on the 3D printing filaments we used, just to make sure we have the appropriate filament for our application. While 3D printing this model, I also had to configure various settings, including layer height, as well as infill amounts to achieve a balance between accuracy and strength. So if you reference the bottom of the screen, that's kind of a simulation of what the 3D printing process is layer by layer and how it would really be printed. But yeah. In addition to this, I also had the opportunity to work on some coding projects, specifically with the Python coding language. I was tasked to develop a Python script that essentially automated one of our image acquisition softwares, meaning it automated the startup, setting configuration, and camera start for all our different sensors. I was able to do this by leveraging various Windows automation APIs, including PyWinAuto and PyAuto GUI. These APIs really let me interact with our imaging software's graphical user interface and manipulate the elements to our needs. In addition to this, a large part of this project was also going back and revisiting my pre-existing code logic and optimizing it for a better execution speed and also a reduced time complexity. In addition to this, I also made sure to include various error handling techniques just to be able to monitor the software's performance and troubleshoot any issues effectively if they came along the way. But yeah, that's what I did this summer. I'm going to pass it on to my colleague Dexter.
Hello, my name is Dexter. I was a technician researcher here at Haggerty this summer. I am through 2 years of electrical engineering at Western University. I was introduced to Haggerty AgRobotics through the Western Co-op program, where I applied to this position through that program. And when I started this position, I was really excited to see some real life applications of some of the very abstract concepts I'd learned in my classes and my program, and see them applied to real life in the field technology. So one of the first things I did this year was setting up the farm droid up at Smith Gardens in Keswick. We had developed new weeding blades for to enhance the weeding and make it more efficient. So first thing I did was I helped align those weeding blades to the onion beds and rows in the field. We had some challenges because the muck soil was so soft that a lot of time they would sink in. So we had to make a lot of adjustments to the farm droid and its tooling and the tooling bars and everything. But we eventually got it to be very successful. And we were very happy with how it went for the first time using those types of shoes, where we had it weeding 10 acres of onions all summer. And it was very successful with that. We found that it was weeding approximately 60% of the total weeds in the field, making it very easy for someone to follow behind and get the inner row remaining weeds. So we were very happy with that. And then more with the farm droid, more on the research side too. I did a lot of weed counts where I would go ahead of the robot, count how many weeds there were, then go through and then count how many it had gotten to get those numbers on the efficiency and what percentage of the weeds it was getting, to see where it could improve, maybe what blind spots it was hitting, where it could get better, maybe identify some of the issues with the shoes for the next versions, but also to give just for data collection and give to the business team for them to use for their materials. once the onions were too big up in Keswick to use for the farm droid anymore, I switched the farm droid to seeding mode for use for trials at the Muck Crops Research Station. And then after that, I also helped prep it for the farm show where we seeded and then switched it back to weeding, where it's been weeding there for the last couple weeks. Another thing I worked on was the Nexus. So I would do a lot of mapping all the lettuce there, and it was a bit of a challenge because the rows there were very uneven. They were not playing with GPS. So it took some time to get those rows dialed in exactly perfect to have no damage towards the crop and have the robot where it needed to be. But eventually we got it there where it was running very, very well, not hitting any lettuce and going right over. I also had to spend a lot of time maintaining the robot. There was a lot of stuff to do with like refueling and also just general maintenance for like connectivity and like the engine and stuff. A lot of stuff I had to do related to that, trying to get it going. Also, I had to do this while communicating with the team over in Montreal, that they were the ones giving me a lot of instruction actually running the robot. I also had to I would determine the effectiveness by doing similar things where I would count the weeds. Well, also I would supervise it to see if it was going up and down, make sure it was getting weeds, make sure it wasn't clipping any lettuce or anything, make sure it wasn't taking out any lettuce altogether. And I was communicating all this with the people in Montreal. So that was a very interesting experience working with people who were so far away and sometimes had a language barrier too. So that was very interesting. So for the second half of the summer, I spent the majority of my time working with the piquetta. So what I spent my time doing is I would go out, I would collect tissue samples from the fields, and then I would bring them back and scan them into the computer using the piquetta. You can see a picture of it being scanned in the top right there. So the main thing I collected the most was onions, because that's what their onion model is very good and we're refining it. But I also did some early work helping create models for carrots and celery. And in the bottom right there, you can see an example of a spreadsheet showing the results of what the piquetta would spit out at the end, showing color-coded to those percentages of all the different nutrients, because it would scan it and it would give you numbers and percentages of all the different nutrients that are inside of the leaf tissue. So it was very cool technology to work with and something you can see mass potential for in the future because of how easy to use it was. So it was very cool to be a part of developing that and making it better for the future. And the last was I helped out a bit with the Nile Oreo while it was up at the Muck Research Station. I did a bit of a field mapping where we had to map fields differently depending on what tooling was on the back, different size cultivators, how many rows. Sometimes it would have to be every other row, sometimes every 3 rows. I also did a fair bit of help troubleshooting it there with the people at the station. I did this both communicating with the people over in France, from them, but also mostly with Grant, communicating with Grant on what needed to do, going through the robot, checking logs, stuff like that. I would also just supervise it, making sure everything was going well, watching for any issues that arose that we could potentially tackle later. So that was very cool to help out with that. That's all I have. I will now pass it off to Jing for more of the business side.
Sounds good. Thank you, Dexter. Just as a heads up, I'm going to do a quick switcheroo of screen sharing. So I'll be starting sharing my end over here in order to proceed with what we have. Just give me a quick second. It's been a while since I used Zoom. Give me a quick sec. All right. Can you see my screen right now?
Yes, we can.
All right, perfect. So my name is Jing, and I am the guy who was in charge of figuring out the RI calculation over the summer. So before we dive a little bit deeper into my kind of work, I'd like to give a little bit of information regarding my background, because it does not stem from agriculture. I am very, very far away from agriculture. So prior to Haggerty, I was a student and I graduated from the HB program at the Ivy Business School. And Ivy, as a university, allowed me to analyze a lot of case studies from various industries in this case. So I've dealt with marketing, fashion, banking, PR, supply chain, operation, technology, and Ivy also is a great platform to allow us to interact with business leaders of industry giants such as Amazon and even Microsoft, who often are Ivy alumni coming back to give us some insights and lessons they've learned throughout their years in the industry. And this is a great way to also develop your network. So I'd like to maybe highlight one of the fellow alumni that has came back to one of the previous cohorts, not mine, unfortunately. And that guy is Kevin O'Leary. So he's the guy from Shark Tank or Dragon's Den, but he is an Ivy alumni from the MBA program in 1980. So that was something that I just learned upon graduation, that apparently he is also a guy who attended a similar school to mine. So this boils down to one question. Why did I choose Haggerty to spend my summer? Well, I wanted to explore a brand new field of an industry between my graduation and my full-time start at Deloitte in consulting in the new year. And AgRobotics seems to be this emerging new field that was very exciting, right? And I initially heard about some robots being able to harvest, till the field autonomously. And I was like, wow, that's so cool. Took a look at it. The robots look cool to begin with. So that caught my attention. But also the fact that it could also help to address some maybe of the labor challenges that we're having as Canada is experiencing an aging population. So maybe this robot could address some of the labor shortage. Moreover, this seems to be an industry that's about to start, it's about to explode. It's about to grow. It's in the early growth stage, and seems that it's going to revolutionize how we do farming, has a lot of potential to change the landscape of a lot of the industry. So I wanted to learn as much as possible. So Haggerty was hiring students. I was like, this looks to be a perfect opportunity. I reached out, and look at me, 4 months later, here I am presenting this to you guys. All right, so that's enough about my background. Let's talk about my project at Haggerty, so the ROI calculation, how we came up with that. So between my introductory talk with, Haggerty, but also looking at some of the recordings of the working group, I've noticed that there was a simple question, pretty straightforward, that a lot of people wanted to know about, is how do you calculate an ROI for an AgRobotics machine? That's a very simple question, a very complex procedure to pull off. So I was working with Jason and Curtis extensively over the summer in order to plan how we're going to approach this and work on this and to collect all the data necessary in order to make the calculation. And we have came up with 3 objectives that we wanted to work towards as kind of a plan in order to tackle this challenge. So the 3 objectives are, number 1, we want to have the ability to break down the savings and all the expenses in a comprehensive manner, right? So that you can see how we calculated return on investment as well as the payback. Second objective is that it needs to be customizable to the end user and it has to reflect their reality. And the third objective is it has to need to have the ability to work for a wide range of AgRobotics platform. All right, 3 objectives in mind, wonderful. And so the journey starts. To tackle objective 1, we want to break down all of the items out there. So the first steps that we wanted to do is we wanted to find a reputable source of data. So we're using MuckStation data, we're using Omafra, we're using industry-wide reports. We've even reached out to growers to give us some data about this, and we're using Haggerty data that we collected in previous years of trials. So we analyzed a lot of aspects in order to come up with the numbers. I'll just name a few areas: germination, weeding, harvest, as well as some experience using the robots, such as the grower experience, operator experience, and then the actual robot's performance in the field. And all of these were combined together in order to capture the savings and expenses in the following graphic, so that you can see line by line items as well as a summary at the top as how does this robot perform for a specific setting. So with that being said, this actually meets our objective 1, which is, this is how many savings expenses we have. Here's how we came up with the return on investment as well as the payback. Let's move to objective 2, which is it needs to be customizable. It needs to represent the reality. So 2 aspects, customizing, and it has to be fairly accurate to the industry of farming. So the challenge with making it customizable was it was hard to go from a hard code to a soft code element. And by that is that the initial versions of the calculator had kind of a pre-filled numbers. By that, the farmer will select either a choice of 20-foot field cultivator, that, as you can see on the slide, and then by industry reports, it says that this type of tooling should cover about 9 acres per hour used in an industry conventional way. The challenge about this is that some farmers have different size of cultivator and some farmers go at different speeds because the soil conditions are different. So therefore, we need to figure out a way how to make this flexible and customizable enough, which led to the bottom picture over here, allowing the farmer to input their own cultivator weight and the speed that they're going through the field, which automatically translates to how many acres he'll cover per hour. The other challenge regarding how to make it realistic to this industry really stems back to my background. So connecting back last summer, I was working with Deloitte on the operation transformation aspect. And for those type of client, whenever they reach out to us, it's because they have trouble and they have issues looking at the data. It's very opaque. So therefore, they don't really know what's going on, or if they do, it's a very vague idea. Compared to farming, where the farmer basically knows the operation at the back of their hand, or at the very minimum can make a very good educated guess. So this means that I was working with my previous experience, I was pre-populating a lot of the stuff as I've done last summer, because what I did in my previous work is you'll look at different case studies, near peers, figure out something that can translate, adjust on the numbers and say this is what we could expect, and use many proxies to estimate what's going on. But farmers, in effect, they know so much about their own farm, they can directly plug in those numbers in. So I had to make a few modifications in order to allow the farmers to do so. So that is a topic that I learned about farming industry, and this is something that I'll carry on forward, that, hey, this is something that farmers know, and this is something that is a little different than the industry I was dealing with. So with these two elements, this is how we made it customizable, as well as how we represent the actual reality of the industry. So what is next? You probably noticed I haven't tackled objective 3, which is how to bring this ROI calculator to a wide range of AgRobotics platform. It's because we're working towards it, and we're going to implement the following plans in order to reach that objective. So the first one is wanted to extend to field testing. We're going to bring this ROI calculator to farmers out there, get it tested out, get their feedback, implement the lessons that we have over here, and then keep doing that, reiterate, come up with a list of these, and then use all of the things we've learned so far in order to come up with a procedure to expand this calculator to other AgRobotics platform. And with that being said, this wraps up the presentation that we have as Haggerty Summer Tech. We hope you appreciated this presentation, and thank you for your attention.
Excellent. Thank you so much.
Just before we get to the questions, I just wanted to mention, like, this presentation was a testament to the hard work that everyone did. And yeah, everyone worked very hard this summer. They all did an excellent job and had to overcome many challenges, including the weather and a lot of the adaptability that we had to develop, and being flexible with different schedules to account for the weather. Yeah, hard work, adaptability, and the team was very receptive to feedback, and that's kind of how we got here today. And everyone learned a lot and grew quite a bit, I'd say, from the beginning of the summer. So it's been great working with you guys, and yeah, y'all did a very good job.
Awesome. Thanks for adding that, Jason. I'd like to open the floor if there are any questions that anybody has for any of the interns.
I've got a couple of comments.
For a bit. Okay. Can I use your desk soon? She's come back to nap at 10.
Sorry about that. Joe, go ahead.
Yeah, Kate, tremendous presentation. Can you pull together, there's just one more slide I'd like to see on the end of that. Just a kind of tracking of the metrics. So, how many impressions, just to track and pull that all together. That was, that was terrific. This is for, I think is it Jing, the last guy? So, where are we? Did you program up a model on this, or do you have a model? Like how far are we away from placing in, the cost of the platform, operational costs, kind of estimating some benefits? Like how far are we from a working business tool here?
So currently, the way that this is working is that we have a Excel that we can input a bunch of numbers in. Right now, what we want to do is we're very close to have a minimum viable product, which means that the numbers will work. And then we're at the stage of we're going to go out, ask growers, get their feedback in order to basically make sure that it's accurate. So do a lot of stress testing. As for how long it will be to be as a working business tool that is public facing, Jason, what do you think would be the best estimate for that?
I think it's gonna be like it's gonna come out in stages. Like the initial version is gonna be quite complicated, I think. So we're gonna have to work with growers.
Well, I think we can dummy it down, right?
Yeah,
So,
well,
right now, whenever we get that ROI question, we look. So I think if we can get Chuck to have a look at it with you, Jason, and I'm happy to help too. Let's get a prototype MVP going. I'm happy to hear you have the spreadsheet, because then we can kind of code it and get something going. Because I think that's really a critical one. Because almost every presentation we hear that same question. What's an ROI? What's the payback? Is this a good business opportunity or business deal? I don't know, Chuck, what's your gut on that? Because you answer that probably, I don't know, 10 times a day.
Can you guys hear me okay?
Yeah.
Okay. Yeah, like this is one of the reasons for the project. And I think when I looked at Jing is being a little modest, the model is built already. But it was just overly complicated. And that is actually the process that they are going through is simplifying it to make it more presentable to growers. So I think they're a little closer than they're letting on. And the other thing that we're trying to do is we're trying to build a model that will work across platforms, and we kind of think that we're going to be able to do that. So I'd imagine that the Farm Droid will be the first model that'll be released, followed by a platform robot like an Oreo or a Roboti. That'll probably be number 2.
Great. Yeah, and just one last comment for Thomas, Hassan, and Dexter. That tremendous presentation, everyone. So thanks, Jason and Chuck and Curtis and the whole team. So congratulations on this, and good luck in your school year.
Thank you very much.
Thanks.
Awesome. Thanks for those comments, Joe.
Yeah, I'll just second that. Great work, great projects, great experience. If I was going to ask one question is, what was most valuable to you as students in this experience? Anybody can answer.
So I could probably address that. I think the biggest thing I found with this co-op was that there was something new every day. You're learning something new every day. It's not the same redundant tasks. And that's something that I think all of us here really value. Just kind of like actually applying the concepts that we learn in school into like a real life experience and bridge that gap between like classroom learning and actual real life applications.
Yeah, because it's such a small company, we have to be so interdisciplinary within what we do every day. So it's pretty cool to do so many different things every day, like Hassan said.
Gotta wear a lot of hats.
Yeah, exactly.
We had a couple of questions from Giuliano in the chat. The first one is for Kate. What makes a website out of date? Is that just related to content, or does it include look and feel elements?
For this one, it was mostly just in terms of content. The majority of the website hadn't gone through any major changes since 2021, and we've done a lot of things since 2021. So there's a lot to add. We have a lot more robots than we had then, so we had to update all of those, and just like all the information just had to be changed a little bit.
Perfect. And the second question was for anyone in the group who can answer or wants to answer. Based on what you've seen and experienced, where do you think we currently are with respect to readiness for greater adoption? Still lots of challenges, or are we reasonably close?
I think it definitely depends robot by robot. I think the Farm Droid is very close. I think it works very well. I think definitely the ones that currently have the ability to seed are very, very close. Something like the Oz is also very close. The Oreo is getting there. It's still definitely seeing, we're still kind of figuring out its full capability. So you kind of have to do that before you can really see what it can do. But yeah, I think it definitely depends robot by robot. So like the farm droid's close, something like the Nexus is farther. So it kind of depends.
Yeah, just to add on to that, specifically for the TED and Vineyard applications, I do think we've made a lot of progress to having kind of like a finished model and being able to like use it commercially. Specifically for that robot, it's a matter of just like I was presenting in some of my slides, getting an accurate map, making sure it's accurate to the vines, and then interconnecting the field together. That's kind of like the main chunk of it. But once that map is really made, the robot is good to run for many years with minimal changes until the vines themselves grow and change and bend in different ways, and the map needs to be updated.
Yeah, and to add to that, what he's like with the TED, we are at a point at Cave Springs where we are comfortable just leaving it completely. We can go get lunch while it's operating, and we're comfortable with it working while we're gone. So that's kind of dictates how we feel about how comfortable we are with these robots running autonomously.
Awesome.
I'll just add a comment too in that it just takes a lot of time and effort, and I think sometimes the companies themselves underestimate how much effort that takes, or they overestimate the capabilities of their machines, and that's something that's an ongoing thing. But every year it gets better and better and better, and I think the work that we've been doing, the work through the working group, and some of that's why we're doing this work, is to try to make this happen.
Absolutely. We had another question from Izmir. She wonders if you share the results of your work with companies like FrontLink or NIO to adapt the robots.
Yeah, we do. Yeah, we're appropriate. Yes, we do.
Perfect.
And often, like even like FrontLink, for example, has called on us for support, for robots that are kind of outside of the area that we cover.
Excellent. Thanks, Chuck. Are there any other questions for anyone, any of the interns at Haggerty? No? All right. Thank you very much for taking the time to join us and to present on what you've been working on in the summer. It's much appreciated.
Can I add another comment there, Dan?
Yeah, absolutely.
So I think we've heard this a little bit before about, kind of the changing face of agriculture and agriculture technology. And, we've heard it said that perhaps some of this technology might encourage some new entrants who didn't consider agriculture in the past. And I'm hoping that the group has seen that is a real thing. Agriculture is kind of where it's at least for today anyways. So it's nice to hear from the students that are not from a farm that this has attracted them to it, and hopefully they stay in the agriculture sphere.
Perfect. Thanks again, Chuck. All right. With that, we'll move on to the next section of our of the meeting. If anyone does think of any questions, you can feel free to shoot them over to me and I can connect you with them, or you can connect with them directly if you have their contact info. For conferences, meetings, field tours, and demonstrations, a new one on the list there is RoboBusiness, October 16th, 17th in Santa Clara, California. And also not on the list there, but it will be on next week's, is the FIRA USA. That's taking place October 22nd to 24th in Woodland, California. The link for that is currently on the website. And I also just added it to the chat there for anyone who is interested and wants to take a look. Has anyone been to anything recently that they have any comments on or would like to speak on? No? Okay, perfect. This week we don't have any new project updates. But for funding announcements and opportunities, the North American Ag Tech Accelerator has been added to the list. The deadline for applications on that is October 30th. So the link is there if you want to look into that some more. And a reminder that the Zone Ag Tech program applications close on September 2nd. So if that's something you have interest in, we're coming up on the deadline for that one. That's Sunday? Monday. At this point, I'll move us into the roundtable section of our presentation or the meeting. And I'll actually start because I see one of our new members, Daryl Finnegan. It looks like they are in the chat. So I'll put you on the spot a little bit, but I'll ask if you want to give a brief introduction to yourself.
Yeah, I've been on a Zoom for a while. I guess I see my background's out of date there, but yeah, I'm in partnerships at Agriculture and Agri-Food Canada. So I'm trying to connect AFC scientists with people working, outside of government in private sector or academia or NGOs. Very interesting presentations today. Thanks for letting me sit in. Sounds like a fantastic experience for all the students. I sense some trepidation of going back to school there, but also some excitement. So, but certainly, sounds like a lot of learning and some of that real hands-on life experience that Chuck was talking about. So, fantastic. I got out to 2 of the demos this summer, which were great, and it was great to see the behind the scenes on the social media too. I think that's great too. I think with adoption of new technology, you need both of those. To be happening. So that's great. I was recently down in Leamington at a private research facility. Some people on the call probably know about. And so I was just thinking about, there are a lot of opportunities, and a lot of this was about field crops, but I think there's a lot of opportunities for all the engineers in the greenhouses as well, right? In those inside the greenhouses robots. So I'm kind of exposed to a lot of these things, but it's really exciting to hear where this group is going, and that you're sharing in this way. And yeah, that's what I wondered is like when are the farmers gonna jump in, either through a subscription model or through through something like where they go and buy one of these sort of, if they have a small market garden, buy a little nano or something like that. So yeah, awesome presentation. Thanks for letting me sit in. It's great.
Awesome. Thanks, Daryl. Yeah, so roundtable, is there any questions, comments, queries, thoughts?
Anybody going to FIRA?
Well, we're likely going to send someone down. We just don't really know for certain yet.
Yeah, 3 of us from the Muck Station are going, myself, Kevin, and Jeff. Jeff's submitted an abstract.
Awesome. So if you head down there, you see some familiar faces. All right then. Reminded everybody that we've got some new interesting articles there on robotics and agriculture. So definitely check those out if you want to stay up to date on some of the goings on in the industry. And I'd also just like to remind everybody about Canada's Outdoor Farm Show. It's coming up September 10th to 12th. The AgRobotics Working Group will have a presence there, as well as Innovation Farms Ontario. Haggerty Creek will be there. So yeah, definitely if you're able to come and check that out, say hi, see some people in person that you might not have before. And with that, I think that will bring us to an end for this week's meeting. Perfect. Thank you everybody so much for joining. Have an excellent long weekend, and we will see you on September the 6th.
Thank you, everybody, for
Thank
listening.
you.
And thank you again for presenting. Take care, everybody.